class, this is part 1 of section 5.2, graphing polynomial functions. Okay, so what we're going to do is with each graph we will determine the end behavior of the function, find the x and y intercepts, determine the real zeros of the function and the multiplicity of each zero, and also whether the graph touches or crosses the x-axis at the corresponding x-intercept. We will determine the maximum number of turning points and also sketch the graph. Okay, so number 1 is x times x plus 2 quantity squared. Okay, so without multiplying it out, we should see that this is a third degree polynomial. So the graph, the end behavior of the graph is going to look like y equals x to the third power. Since it's degree 3, this means it can have at most 2 turning points. Okay, so the end behavior is the y equals x cubed. I'm going to write that over here. For the end behavior, this helps us to graph the function, so we need to know which quadrant to start in. So when we graph it, we'll start down here in the third quadrant, and we need to end in the first quadrant. Okay, next we want to find the zeros, state the multiplicity, and then also what the graph does. Okay, so since our function is given to us in factored form, it's easy to find the zeros. So 0 and -2. The multiplicity of 0 is 1, and the multiplicity of -2 is 2. We get that by looking at the exponents. The exponent on the x is a 1, and the exponent on x plus 2 is 2. Okay, so remember the graph crosses anytime there's an odd multiplicity, and the graph touches when there's an even multiplicity. Okay, so our x-intercepts are 0, 0, and -2, 0. The y-intercept is at the origin as well. So we get the x-intercepts because those have to be, the zeros of the function are the x-coordinates of the x-intercepts. Okay, so I think we're ready to sketch the graph. So the origin is a point on the graph and also to the left at -2. When I graph my function, I need to start down here in the third quadrant. When I get to -2, I'm just going to touch the graph, meaning I'm going to stay below. At some point, my graph needs to turn and go back because at the origin it crosses. So I can see that I'm ending in the first quadrant, which is good. That matches the end behavior that I said I would have. Looking back here, this needs to match, and it does. Okay, so let's see if we got everything. We stated the degree of the function, the number of turning points, the end behavior. Again, the way the textbook words it is it asks what the function looks like for large values of the absolute value of x. Okay, so again, that just means when x is really, really big and positive or really, really big and negative. Okay, so that's when the graph is either down here or up here in the first quadrant. We have the zeros, the multiplicity, and we have our intercepts. Okay, so I think that's it. Notice on my graph, I only have points along the x-axis marked. We don't need to put any points along the y-axis. Okay, so again, third degree polynomial, positive leading coefficient, so the graph looks like y equals x to the third. So that's our end behavior. The reason why I have this gap here in the middle is obviously this function here goes through -2 and through the origin. So the end behavior just tells you which quadrant to start in and where to end in. We have our x-intercepts and the y-intercept, and we have our table. At most 2 turning points. And then there's a sketch of the graph. Okay, the second one. This time the degree of our function. So let's see, this is x plus 4 to the first power, and then I have x minus 3 cubed. So the whole thing is degree 4. So there's at most 3 turning points. The zeros, or let's do the end behavior next. Okay, so that -1/2 out front is going to make a difference, the negative more so than the 1/2. And then since it's degree 4, -1/2 x to the 4th power. So we're going to be down here in the 3rd and the 4th quadrant. Okay, next we have zeros and the multiplicity, and then also the graph. What's going on with the graph? Okay, so the zeros of our function are -4 and 1. Again, our function is given to us in factored form, so finding the zeros is easy, should be easy. It takes a little bit more work to find the degree, but getting the zeros is the easy part. Okay, the multiplicity of -4 is 1, and the multiplicity of 1 is 3. And again, we get that by looking at the exponents here. So our graph, odd multiplicity for both, so the graph will cross at both of those x-intercepts. Okay, so the x-intercepts, -4, 0, and 1, 0. The y-intercept, so let's plug in 0 to our function, see what we get back. So we're going to let x equal 0, then y will equal -1/2. 0 plus 4 is 4, 0 minus 1 is -1, and that's cubed. So -1 cubed is -1 times -1/2, so those negatives will cancel. So we have 1/2 times 4, or 2. So 0, 2 is the y-intercept. I'll just fit a graph down here real quick. 1, 2, 3, 4 to the left. So -4, 0 is an x-intercept. 1, 0 is as our other x-intercept. I'm going to start the graph down in the 3rd quadrant because I'm looking at my end behavior. When I get to -4, I'm going to cross. When I get to 1, I'm also going to cross, which means I end up down in the 4th quadrant, which is good news because that's where I said I was going to end up. Okay, you don't have to do this, but if you notice when I crossed at -4, it was kind of like a smooth crossing. If I zoomed in, that would look linear, and its multiplicity was 1. Over at x is equal to 1, when this crosses, it kind of looks like it has a squiggle in it, and that's because the multiplicity was 3. So if you were to zoom in on that function, it crosses over kind of like the x cubed function does. So if you zoom, it should look more like the x cubed function as opposed to something linear like the line y equals x. So if the multiplicity is 1 and you zoom in, it looks linear. If the multiplicity is 3 and you zoom in, you'll get that squiggle. Okay, good. So just to go through it again, degree 4, end behavior, -x to the 4th. So this is fine. You have to have the negative because that's what makes it open down. Okay, but it doesn't matter to me if you keep the 1/2 with it or not. The picture is the same. And then our x-intercepts and the y-intercept of 0, 2. We have our graph, so -4, 1 are the zeros, the multiplicity, the graph crosses at both. At most 3 turning points. And here's the graph of our function. I've mentioned this before, but Desmos doesn't put arrows down here, so you should have arrows with what you're turning into me. The fact that the graph has at most 3 turning points means that it could have one more, right? So we see a turning point up here at the kind of at the top in the 2nd quadrant, and then it kind of makes a squiggle over here at 1, and then it goes down. So our graph only turns twice. Turns out that's as much as it turns, right? But otherwise we wouldn't know whether it makes one more. I guess it can't make one more turn because then it would go back up, right? And it has to, we can't change our end behavior. Okay, so the turning points is just the maximum number of turning points. But as you can see here, our graph only turns twice. Oh, one thing I forgot to mention, the y-intercept, I didn't plot the y-intercept on my graph. You just want to make sure that you're on the correct side of the x-axis. So when I graphed the function, we had a point at -4, 0, and at 1, 0. I started down in the 3rd quadrant. We went up a bit. I had the squiggle through at 1, and then came down. Okay, so the y-intercept, we're not going to have points labeled along the y-axis. But since the y-intercept is 0, 2, it does need to be a positive value, which is true for our graph. Okay, so number 3, this is for you to complete and turn in through Canvas. So the function is 5x times x squared minus 9 times x plus 4 quantity squared. Okay, so the hint is to factor first before you get started. This is mostly factored for you, but not all the way. So you want to factor it all the way before you start. Okay, or at least before you determine the zeros of the function. Okay, good luck. Let me know if you have any questions.